Hello friends, welcome back to my channel. In today's video, we are going to explore the Rebrickable LEGO dataset, and we're going to answer some specific questions relating to that dataset. I already have a video of this same dataset, but that video is in SQL. We are going to answer those same questions we answered in SQL, but this time with Pandas in Python. I'll share a link in the description below to the SQL video, but here is it on my page. It's called Real World Data Analysis, Exploring LEGO Dataset. I have the same dataset analyzed in SQL, so do check it out. But I got a request to do the same video and answer those same questions in Python, so let's get into it. So for the dataset for this demo, let's go to rebrickable.com. Now on their website, you want to go to the Other tab and you click on Downloads. I am already on the Downloads page. Over there, you see the schema diagram, you see the database itself, they are zipped files, and then you see the images of the Lego parts, right? For this demo, we need the themes, the colors, sets, and then inventory parts. So we need 4 of the 12, okay? Only 4. We need the themes, colors, sets, and inventory parts. So download them, and then when you download the files, you realize that they are zipped, okay? For me, I have WinRAR on my computer, so I just have to right-click and then extract the files to get the actual CSV files out of them. So do the same. I hope you have some type of software to help you with that. So extract, I have all the 12, but I said we are only using 4 of them, okay? So download the 4, and then the demo is going to be in Jupyter Notebook, okay? So if you do not have Jupyter Notebook, you can also go to anaconda.org and then click on download. Depending on your operating system, it will give you executable to download and install. So go ahead and go through that process. And once you install Anaconda, then in your search, look for Anaconda Navigator, okay? Then you want to launch Jupyter Notebook. So once you launch Jupyter Notebook, it will take you to a browser. Depending on your default browser, I have Google Chrome. So it takes me to my Google Chrome browser, and then it opens my directory. So I just have to navigate into the project folder. So as you have downloaded the files, you want to put the files in some type of folder. For me, I've put my files in a folder called data source. So I'm in this same folder here on my Jupyter Notebook. Okay, if you look at the path, you see that I'm in the same folder. So I'm in the Python folder right now. That's why you see the data source and you see the data source here. So navigate to your project folder so that you can get started, okay? So for this demo, I have a template which I'll share in my GitHub repository, and you can work along with me using that template. But when I click on the template, it's supposed to open in another tab in the browser. I think I already have it opened, but just to show you how to do that. So let me close out of this. So on the notebook, I have the header, which is the LEGO Data Analysis Rebrickable, and I have a brief introduction of where the data set came from, and then I have the data module. Okay, the data module came directly from their website. I just downloaded it, and then I uploaded it here in my Jupyter Notebook. Now, we want to get started with a demo and import some libraries. Okay, so right now we have Pandas and NumPy to import, okay? Now, if you went through the installation just like I showed you, then you don't have to do anything with the installation of Pandas or NumPy. Anaconda installation already have those installed for you, but in the event you run this import and it fails, then you want to do something, you want to install Pandas before you do the import. Now to do that, let me just move this cell above here. If you don't have Pandas already installed, the import is going to fail. So to help you out with that, you want to do pip install, okay, and you type Pandas. All right. Once you run that, you'll be able to successfully import Pandas. Okay. Pandas library help us with data analysis. So let's run import. Okay. So now that we have our libraries imported, we should get the data. Now to get the data, we're going to use Pandas. We imported Pandas as PD. So I'm going to do PD, and remember the files are CSV. So I'm going to do read CSV. And then I'm going to open parentheses and pass in the path to the file. Sorry, I need to put in quotation. Data source /sets.csv. Okay, so this is how you pass in the path to the file. Remember, my working directory is the Python folder. However, my data sets are in another folder in my working directory called data source. That is why I had to pass that folder before selecting the name of the file. In the event I had my my files in the same directory as my working directory, then I'll just pass the name of the file and the extension, okay, without the folder path here, okay. It would have just been sets.csv, all right. So now let's run this and see how it looks. What we have now is a data frame. We've imported the sets, and then we see that we have 18,914 rows and 5 columns. Okay. Now I want to put this data frame in a variable called sets. So I want to do this sets, right? Now once I run this, because the data is now in the variable, I have to call that variable to see the data set now, right? So this is the data frame. The next one that I want to import is the themes. So I'm going to copy and paste, and I'll call this themes. Copy that, paste it here, and paste it here. Okay, so I'm going to run that. Okay, so the themes are also 3 columns and 444 rows. All right, so we're going to go through a few of the basics. We want to see the top 10 rows of the sets data sets. Now remember, we put the sets in a variable or in a data frame called sets. All right, so to see the top 10, we will use head. All right, so sets the head. Okay, now once you run this, you only see the top 5 because that's the default. Now to see the top 10, you have to pass the number 10 here. Okay, remember in Python, the indexing starts at 0, so you see 4, but it's 5 records. Okay, so let's run this and see. Now this is the top 10. All right, now let's quickly go into the next one, display the last 10 rows. So I'm going to do sets. Now this time I'll do tail. And with the tail, again, the default will give you the last 5. Now we want the last 10, so I'll put in 10 and run that. Perfect. The next thing we want to do is to check the data types. So I'm going to do sets.dtypes, I believe type or types. And remember that that is not a method. So I won't put it into the, I won't pass a parenthesis at the end, right? It's almost like an attribute of the data frame, I believe. So we have the set number and the name to be objects. And then the year, theme ID, and num parts are all integers, okay? So these are the data types. Now to check for nulls, we're going to sets, and then we can call the isNull method. Okay. Now this is going to give us a Boolean series, true or false. Okay. Now how do we know that there was some type of null in here? Although we see false, we have a lot of records here, so we have to pass some aggregate function. Okay. So we want to do a sum on here, and now this tells us that in the sets column there are no nulls, and there are no nulls in here. So maybe actually let me copy this and paste it here and see if there are any nulls in the themes dataset. Okay, but before I pass the sum, let me just run this and see, just to show you. Okay, so obviously, well, I don't see any true or false here. I only see false in the first 2 columns. But for the parent ID, I see true and false. So I'm sure that if we do the sum, we should have some null values. So run this. Yeah, so see that? Parent ID, we have over 100 records to be null. Okay, 138 are null. Okay. The next thing we want to do is that we want to see how many rows and columns are there in our data sets. So to do that, we can simply do the shape. Okay, sets.shape. And if you run this, the first index, the first record here, gives you the total number of records in your data set or in your data frame. And then the last record here gives you the total number of columns. So this is an easier way to see both the rows and the columns together. But if you wanted to see just the columns, you could do this. Sets.columns, columns. Okay, now if you run this, you're going to see the total number of columns in here. Okay, their names, but then we want the count, so we have to do the length. It gives us the length of the columns. All right, so now this is the 5 that we saw here. So again, we can do something similar for the total number of records. Now, if you type in sets and you run it, you see the entire data frame. Okay. Now, if you want to see the count, we just pass the length again and run that. And just like we had here, the same number. Okay. So this is the total number of records. We can as well do something called use the info method. Now, the info gives more details. It tells you the type of data set it is. The class of the data, which is a data frame. It tells you the total number of entries, which we have here. Okay, so these are the total number of records. And it tells you the total number of columns. And even tells you the data types and whether we have nulls or no nulls in there, right? So this is another way to see the total number of rows and columns in your data set. All right, so let's move on. Merge data. So we are joining two data sets to answer the questions. Okay, now we've only imported two data sets. We have the sets and then we have the themes. Where is that? Yeah, we have the themes and we have the sets. So those are the data sets we're about to merge. Now in Python, in Pandas, to merge data, you want to call the merge. So pd.merge, okay, open parentheses. And then I'm going to pass the data set that I want to merge. So I want the sets and then the themes. I believe the first data set that I call is the left data set, and the one on the second one that I call is the right data set. I could be wrong, but that's what I think. And then you want to pass how you want to merge data, right? So you pass your how. I would say left, okay? And then for the left, you have to do how are you going to join the data, merge the data. So left, I want to remember I said the left data is themes. I will need the theme ID from the sets data, right? So for the left, I would merge on the theme ID, which is coming from the set data frame. Okay, and then right on. The right is going to come from the themes, and that will be the theme ID. Okay. And then I'm going to pass something called suffix, okay? I'll explain in a bit. Suffixes. And then I'm going to say that the first one will be underscore sets. And then the second one will be underscore themes. What I've done here is that when I merge the data, in the event there are names that matches in this data frame. So for the sets, we have name. And I saw that in the themes, we also have name. So to distinguish between which is which, I want to pass the suffix. So the data set that comes from the left, if the name is passed and they have the same names in the two data sets, append sets at the end of the left data and append themes at the end of the right data so that I can see the difference, okay? So let's run this and see. Okay, so you see here, name sets, and then name themes. This is why we had to do that. We had name and name, okay? So this is a perfect way to distinguish between the data set. And now since we merged the data, the total number of columns have increased. Remember for the sets, we only had 5. And for the themes, we only had 3. Yeah, we only had 3. Now, because we merged them, we have 8 columns, but the count is the same, okay? I want to pass the data frame that we just created to a variable, and I want to make it self-explanatory. So I want to call it sets and themes. All right, so run this. Sets, themes. All right, so for this, we can simply do some of the basics that we just did, like the head, the columns, you know, not necessarily required, but just to show that you can do all those stuff. We can do the info. All right. Perfect. And then maybe we can even do the columns if we want. Sets, themes, dot, columns. All right. So yeah, we are done with the basics. We went through some of these pretty fast. I'm sure these are not difficult to understand. But now let's get into the questions and see how we can answer the first question. The first question is, what is the total number of parts per theme? So before I even go into the question, I will definitely need my data frame. So I would have to do a group by. What is the total number of parts per theme? So I'll do a group by, and I'll do a group by on themes. What do I call the themes? Name themes. Let me copy this name here. And then I have to pass an aggregate, and I'm going to do the sum, total number of parts. Give me 1 second. Yeah, number of parts is an integer. So if I do a sum, I should be able to see the total. So let me run this and see. Perfect. And then I want to do the reset index function and run this. Good. So now we have reduced the data set by doing the aggregate function here. We did the sum. So now the data is reduced from 18,000 to 356. I want to pass this data frame to a variable like I've been doing. For the name to be self-explanatory, I want to pass this, I want to name it number of parts per theme. That's the question. So let's run this. Perfect. Now in here, let me call this again, and then I want to select only the specific columns that I need, but let's see how it looks anyways. So over here, I want the name of the themes, and then I want this column, and I want that. Okay. Now I'm going to pass double square brackets because the first one will give me the series, and then the second one will help me pass the data frame to get the data itself. So I'm going to do what is it called? Let me just copy and paste. Copy and paste that, comma, num parts. Okay. Now let me run this and see. Good. So this is what I wanted. I just wanted only the names and the parts. Now I think I need to sort it and see how it looks like. So I want to do the sort values. I want to sort the data on the num parts column. Okay. So sort values and open parentheses, and I want to sort on the parts. Run this. Let me sort it in ascending order. Maybe no, in descending order, because this is ascending order, right? So I'll do ascending equal to false because I want descending order. Good. And I'm going to replace this data set, data frame here like that. Sorry, I need to call it again. Okay. So what is the total number of parts per theme? So according to the data set technique, had about 221,198 total number of parts, and then followed by Star Wars. Now, Adventurous theme had no parts, so I don't know why they created that theme. Anyways, so this is how we answer that question. Now, the next question is, what is the total number of parts per year? Okay, we are going to do a lot of copy and paste here because it's the same question, but this time not themes, but this year. Let's be fast. I'm going to change this to year, and I'm going to copy that and pass it here, pass it here, pass it here. Okay, so now over here, instead of name themes, I'm going to say year because in the data set we have year. Okay, so I'm going to type in year. I hope that is it. Year, and then run this and see. Good. So according to the data set, 2021 is the year where they have the most number of parts. They had about 264,827, followed by 2020, then 2019. Unfortunately, after 2019, 2017 is next. It overtook 2018 in terms of the total number of parts produced. Okay, so yeah. So our third question is, how many sets were created in each century in the data set? Now let's check our data set, but I know for a fact that we don't have century in the data set, so we may have to create century. Let's run this quickly and see. Yeah, and then century will be dependent on the year. So you know what, let me create a comment. the comment I want to create, let me change the cell to Markdown, and I want to say that we have to add a century as a derived column to this set themes dataset. Okay, now this is a mouthful. Come on. Okay, so let me see only the unique year in the data set or the data frame. Sorry, dot unique. Oh, I need to sort this because I cannot tell. So what I can do is that I want to pass this to a variable, and I want to call the variable unique year. Let me run that, and then I want to sort that year dot sort. I think it's like this, and then let me call this variable after I sort. Perfect. So the years in the data set starts from 1949 up to 2022, the current year. Okay, so since it starts from 1949 to 2022, according to Google search, we only have 2 centuries in this data set because we have 20th century and 21st century. The 21st century starts from 2001, so all the data from here will be 21st century, and everything below up to 2000 is 20th century. Okay, so now we have to create a derived column. I want to call the column century. I want to call it century, and that column is equal to. Okay, before I do that, let me see those that are greater than 2000. Okay, because that's what I'm going to use to create a 21st century. So cut this and let me run this and see. Okay, so I can use that as my so I'll do np. So I'm going to use numpy here, and I'm going to do the where all that. Okay, we're going to say where the data sets with a year greater than 2000, we want to call that what was it, 21st century. Okay, y century, else 20th century. Is that not how to do this? np where set theme where the year is greater than 2000 because I want 2001. So yeah, then it's 21st century. If not, it's 20th century. All right, let's run this. Oh, sorry, I have to see the data set. So let me add this here. Sets themes. We should see another column called century. Perfect. So let me see if it corresponds to the year 2020. That is 21st, 1979, 20th century. Perfect. So this works. So now we are ready to actually answer the question, how many sets were created in each century in the data set? Now we will do another group by. You know what? Let me go copy some of these. I'm doing a lot of copy and paste because I already explained what this code is doing. So allow me to do some copy and paste so that this video can be shorter. What I want to do here is I want to change this to century, remove the year. And then I'll do group by century. Now I just have to check. You're saying total number of sets. The first one that we did was about number of parts. And now this is number of sets. Okay, so you see number of parts were numeric. They were integers. So the sum would work. Now I cannot sum this string here. I cannot sum, so I just have to count down. Okay, so I have to remove this. I mean, let me just demonstrate. Let me remove all that. That was a good one. So if I run this here and I do a sum, you realize that I will lose the set num. Let's run it. Okay, so now I only see the records where the values are like integers. I see the parent ID, you see, I see the ID, I see the num parts, I see the theme ID, and then I see the year. But I don't see the the set num, the name sets, and all that. But if I did a count, okay, if I did a count, I'll see them. There we go. So now I see the set num, I see the name sets and all that. Okay. So now this is what I want to have as my, because for the question I'm supposed to be counting the total number of sets that were created in each century. So I'll call this num sets per century. I want only a few columns, so I'll select those few, and I have to put in a double square brackets. So I want my century, and then I want, what was the name called? Set num. I want this. Okay, so let me run this quickly and see how it looks like. Oh, what happened? Oh, I see. sorry. Set num. Set num. Is it sets or sets? Set num. Okay, now it's about time I want to copy the name. Okay, run this again. Perfect. Okay, so now we don't have to do anything else. If we want to replace the variable, we can replace it, but I think I'll keep it as is. So now we have the total number of sets that were created in each century, and we see a vast difference between what was created in the 20th century versus what was created in the 21st century. Over 10,000 difference. Okay, so question 3, was it 3? Yeah, question 3 has been answered. We have 14,056 for 21st century and 4,858 for the 20th century. The next question is, what percentage of sets ever released in the 21st century were trains themed? To start, we know that we have to filter the data to only the 21st century. So what we can do is that we have to do, now that we have century as part of the columns, right? We have century like this. We want to filter only to the 21st century. And remember, with Python, it's case sensitive. If I type smaller c, it may not work, right? So I'm going to say where the, or was it 21st century is what I need. Can I not copy that? Yes. First of all, I need to see only the, oh, sorry. And then I have to, now you see I only got the Boolean series. Now I need to get the data frame itself, right? So I have to do sets underscore themes and then open a square bracket again and close it here. All right, now I should get the data. Perfect. So again, remember it's working okay because the total number of records that I'm pulling tells me that those are the counts for the 21st century, as we saw in the previous question. So now I want to name this data set as, can I pass the number first? Or let me just call it century 21, 21st century. So century 21 data, okay? So now I only have my 21st century data. Run this here. Okay, it's looking good. Now I need to only focus on the name, the theme for trains. So I have to again do this. And I'll say where in the 21st century, what was the name, the theme name here? Here, this name is equal to, actually, what if the name is trains? So I have to do this dot str, check in the string, okay? Check in the string for the name themes, okay? And see if it contains, and then I want to find trains. So I'll do train and run this. Okay, so I'm getting true or false. I want to get the actual data frame. So I'll do this. I'll call this again, and then I'll pass my square bracket, close it out here, and run this. Okay, so there are only 63 rows, and everything here is, you see, we have train and trains. So I'm going to call this dataset train instead of trains, okay? So run this. All right, so now we have two different data frames. We have the 21st century data frame, and then we have the trains data frame. So what we have to do is a percentage. So we just have to do a count of the number of records. Let me add another cell. So let me add one more. On second here, train century 21 data dot shape, and then run that in C. And then I'll do the shape of this as well, dot shape, and run this. Okay, now I need to be able to divide the 63 over the 1456 to see the percentage. What I would do is that I would capture, so to capture the first index here, I have to open a square bracket and I'll type in 0 to only get the 1456. And over here, I have to do the same square bracket and 0 to get a 63. So let's run this and see. Run, and then run. So now I just have to use this as my division. So I'll go here and I'll just copy this, divided by that. Run this. Okay, now to get the percentage, I need to multiply by 100. Okay, so the percentage of sets in the 21st century that were trains themed were less than 1%, 0.448%. Okay, so we would go to question 5. Now, question 5 seemed to be similar to question 4, so we just have to create Disney sets. We want to see the percentage of sets released in the 21st century that were Disney themed. So I'll put in here, and I'll call this Disney. Now again, I will still do the contains. I could have simply done equal to Disney, but I don't know the variation of Disneys that they have, so I'm just going to do this. Okay, so yeah, run this, and let me call Disney here and see. Okay, so we have 176 rows. So all that I need to do is that I need to get the shape. Oh, I don't want to keep using the same cell, just so you can track what I'm doing. So I'm going to put in here dot shape, Disney data frame dot shape. Oops, I need to type shape, and then before I do the I extract the total number of rows. I will show you what I did with the shape, and then the first index is 176. That's what we want. So all that we have to do is to do a division, just like we did, but this time instead of trains, we're doing with Disney. So we're copying the same formula here, but not with trains, but with Disney, right? So I'll copy this part, and then I'll run it. Where is that? So I'll multiply by 100, and nice. We had over 1.25% of the entire data set in the 21st century that were Disney themed, right? So you can actually try more of these. Remember, we had okay, so for Disney, we had different variations of Disney. We have the Disney planes, Disney princess, and Disney itself. Maybe you should try the Batman and the Star Wars and all that, right? You can use the same logic to do that. So let's move on to the next question. What is the popular theme by year in terms of sets released in the 21st century? So to do this, I have to group by two things. Popular theme by year. So I'll do the group by on the year and then on the theme. Okay, so I'll go back to the sets. No, so I'll go back to the 21st century. I almost got it wrong. So I'll use this data frame because it says the 21st century. All right. So run here, and I'll do the group by. Now for the group by, I will do it on year, and what was the name of the themes? Name themes. Okay, like that. And then I would do sum, the aggregate function, and then I'll do the reset index. So it is resetting the index of the entire data frame that I'm about to pull, right? So let's run this and see. Oh, actually, I don't have to do the sum because remember I told you that because it says sets released, and I don't even see sets because I did the sum, and the set is a string or an object. So I have to do a count so that I can see the sets. Run this. Good. Okay. So now do I want to put this in a variable? I think I want to do that. So I'll call this popular theme per year. Okay. Run that. And then again, I would only select a few data columns that I need. I don't need to see all that. So I will again open my double square bracket, and I want the year, obviously. I want the name themes here. I want that. And I want, what was it? I want the set num. Okay. The set num. Good. And I'll replace my, I think I need to sort this data. Okay, so hold on. Let me do sort values. Sort values, and I will sort on the set num column. Okay, set num. Run this. Oh, I love to do descending order. So I'll say ascending is equal to false. Okay, I'll run this here. All right. So what is a popular theme by year in terms of by year? So it means we need only 1 year per theme. And according to the data set, we have only about 72 distinct years, right? It's even shown here. We have about 72 distinct years. So I need to make sure that the data set that I'm returning should give me only 72 records in my columns. What I can do is that let me replace this to begin with. And then there's this function function called drop duplicates, I believe. It can help me keep, so since I've sorted this in a descending order, it will only show me the highest value at the top, and then everything else I can classify as duplicate. So I have to do the duplicate check per the year, right? So I have to do drop duplicates, and then I want to do a duplicate check only on the year column. Okay. Again, I'll copy this part of the code to just sort my data. Okay, let's run this and see. Okay. Oh, so I was wrong. Remember, I only said 72 because I was confused for a second because why did I say 72 and my data set is only a few? Let me do the order by year just for you to get my point. So right now, I went over there at the top and I said I'm expecting 72 rows and total number of records because the 72 is the entire data set. Now I'm only focused on 21st century, which starts from 2001. So I don't expect to see 72 rows, okay? So now this is saying that according to the data set, for the year 2022, city is the most popular theme in terms of the number of sets created or released. And then in 2021, we had gear. Now it appears that gear had been the popular theme since 2006, right? And probably because we are still in the early stages of 2022, it may eventually overtake city, probably in the latter part of the year. So yeah, according to the 21st century data, gear is almost like the popular theme, but then for the year 2022, city is the number one, and basically between four or five themes, right? So this is how to answer the sixth question, which is what is the popular theme by year in terms of sets released in the 21st century. Okay, so we did a count on the set, and we took the maximum count per each year, okay, per theme. The last question is, what is the most produced color of Lego ever in terms of quantity of parts? Note, join two data sets to answer the question. Okay, so now remember I said we're going to use 4 data sets, and so far we had only used 2. So now we need to import the other 2. So we're going to get the colors. So PD read CSV, and then I'm going to open parentheses, and then I want to pass the path underscore data source / what was it called, colors dot CSV. Let me see if that's true. Okay, so I would use the same, actually, let me call it colors, the data frame. All right, and then call it here. Good. And then I'll do the same. I did copy, and then I'm just going to change this to inventory parts. Inventory parts. And this was meant to be Y, nothing else. And I'm going to pass that to my data frame. Run that, and then that is going to be called here. Good. So now I need to join those two. So I have to do pd.merge. And then what do I want to call first? I want to call my inventory parts, because that seems to have the most records. And then I'll call the colors, and I'll do a left. Remember we said how. Then over here I'll do left. And then I'll do the left on what. And that is going to be for the inventory and colors. Okay, I'll do on the color ID. And then right on, I would do the right on the ID, okay? ID. And then again, do I need the suffix and the, not necessarily for this one. Yep, I don't need the suffix and the prefix and all that. Did I say prefix? The suffixes. All right, let me run this and see. Good, good, good. So I'm going to call this color inventory. Is that what I want to call this? Run that and select that. Perfect. Okay, so now we have the joined data set to work with. Now, what do we want to do? We want to, what was the question? What is the most produced color of Lego ever in terms of quantity of parts? Because I'll be using the color name for this question, I want to rename it from just name to color name. Now, to do that, I'm just going to copy the data frame here. And I'm going to do rename, and I'll open parentheses, and I'm trying to rename a column. So I would rename, I'll change it from name to color name. Sorry, I need O in my color name. And then I'm going to, okay, so now let me introduce something called in place. Okay, I'm going to say in place is equal to true. Now, once I do that, it would replace my data frame with the changes I'm making without me actually saying the entire data frame is equal to, like doing what I've been doing with the first, previously, right? So basically with the in place, the change is seen in the data frame immediately. Okay, so I'm going to run this. And then if I check my color inventory again, I shouldn't see name, but I should see color name. Perfect. So now to answer the question, what is the most produced color of Lego ever? So definitely we are going to do group by. So this same data frame dot group by, and I'm going to group by the new name that I just created, color name. And then I would do my aggregate now in terms of quantity of parts. So I can do a sum because quantity is integers, right? So I can do sum, and I'll just do my reset index. Okay, so let me run this. Good. So I'm just going to select, maybe let me assign it a variable, and I call it popular color. Okay, so now this color, I'm going to run and see. Nice. So I'm going to only select a few columns that I'm interested in. And the first one that I want is the color name. And then the next one will be the quantity. Sorry, I need the, yeah, quantity. And then I would do sort. I want to sort by the quantity column. All right. So I want to do sort values. And then I'm going to call my quantity column. Wow, I cannot spell quantity. And then I will do ascending equal to false. So let me run this. Perfect. So per the data, okay, you know what? Let me just pass this to the variable again. And then do head. Sorry, undo this. Enter. And then do head. I want to see more records rather than this. Probably let me pass 50 and see. Perfect. So according to the data set, the most produced quantity of color is black, followed by light bluish gray. And then there's white, and then there's dark bluish gray. Like I said in my other video, I expected it to be just primary colors, probably yellow, red to be the top. I mean, black is also one of those that is very common, but light bluish gray, I didn't really expect it. I mean, if you check the quantity, you see there's a big gap between the number 1 and the number 2. So yeah. All right, so this brings us to the end of our LEGO data analysis in Python. I hope you found this video very informative, and I hope to catch you in my next video. Thank you for watching.